trick, that's fine. This trick is pretty cool for doing a 3x3 matrix. And if you're going to find a 3x3 determinant, we have to do all the chutes, then the ladders. Yes, sir?
Do you want, like,
I'm not collecting any. No.
No.
You've done them. You're all getting the points. I don't care. All right? So, if in a 3x3, you'd have to do a lot of chutes and ladders. You agree?
Yeah.
Less
A
chutes.
lot of chutes and ladders.
Now, less chutes. There is a way that you can actually do a 3x3 determinant via 2x2s.
What the heck?
Then try to teach this.
Sure.
Unless the coefficients of the variables are new.
No. Just watch. This is a really nice trick. It may not. It doesn't take any much longer or shorter. It's just a little bit easier on your brain. If I'm not mistaken, right? Please.
Take it away.
So, if you're trying to find x.
No, but just do the determinant. Just show the determinant. How do you do the shortcut determinant? Remember the shortcut determinant?
Notice
Yeah. Circle the 4. Start with that.
4, and the 4 is in these rows, this row and that column. So you cover them up and you do this 2x2 matrix. So it's 3
Get ready.
Minus 1 and 2 is 5 is 12.
minus -2, so you get 5.
What she's doing is she's taking that 4, and it's not touching those other 2 rows. Take the determinant here. So you get 4 times 3 minus a -2, so you get 20. Go on.
Which one's which one?
No.
Which one?
So now you do it again with the next number.
Isn't this one?
Yep.
Okay. So,
Move the circle.
Got the circle. You should be able to circle that.
What? Just kind of so slow.
wait.
All right. Which 2 rows is it touching?
Same one. Well,
The
no,
top
not
and the
same
bottom.
one.
So you do the.
It's going to 4,
1, 6,
negative 1,
negative
3,
1.
3, 2. So you do 1, 6, negative 1, 1.
So 1 minus -6
7.
equals 7.
Negative 21.
28. Sometimes 3. As I said, 21.
And then the only trick here is when you go to the third one, notice how we started with the 4
We have the
minus 3. Now we change it to a plus.
because it's
The
negative.
sign goes plus. No, not because it's negative. The rule is plus minus plus. You just have to change the signs accordingly. So here it's going to be plus a -1 times what's going to be the matrix.
The 1, 3.
1, 6, 3, 2. 2 minus 18 is -16. So it's -1 times -16.
How does this work? Like, why?
So it's one of those things that when you work it through, look at you. Don't drop it.
Moving up in the world.
What happens here is this is just a shortcut if you want to think of it that way. To be honest with you, I don't think it's that much more work, but in my brain, multiplying 2 numbers together is easier than multiplying 3.
Wow.
So that's why you can do it this way.
So is that just what's with 3x3s?
Yeah.
Okay.
If you go anything larger than that, then you have to use a bunch of exponent rules, and it's a big pain in the rumpus.
Are we going to do anything larger than 3x3? Wait.
I'm glad you asked!
No!
Oh, I saw Izzy's
Sorry.
6x6.
So you have I'm going to give you guys a 6x6 Kramer's rule problem for extra credit over the weekend.
Oh, that's
I don't know, I've decided. Yes, ma'am.
Can you use this same thing with the 2x2s in a 6x6?
No, this quick method is only for the 3x3. 2x2 is just diagonal. It's, chutes and ladders. Okay? Yes, I have something else to do. All right. So let's look at 4-4 real quick.
Wait, Mr. Murphy, is that 6x6 from your original?
No, I got stuff for you. We got homework.
I wanted it.
I want to talk about what's called an identity and how you use inverse matrices. I want to talk today about identities and inverse matrices.
Starting to run really low on paper here.
Well, that 6 by 6 will kill out whatever you have left. Unfortunately.
Great.
Woo-hoo.
Is it due Monday, those ones?
Yeah.
That's exciting. So you're gonna pass them out?
I will later.
Got it.
So what happens here with what's called an identity matrix? An identity matrix is a square matrix that has ones on the diagonals. That's really all you need to know about it. The reason that we have these is for using what's called an inverse. What I want you guys to think about here is how you use an inverse. For example, well, like they use a capital letter I for identity. The identity matrix is just ones on diagonals on the shoots diagonal. You will use those when you guys take an upper level algebra class in college. So if you go into engineering and stuff like that, you start to see the more importance of these things. Yes, ma'am?
Does it have to be zeros? Or
Yeah, it has to be ones, but everything else is zeros. So all just ones on the diagonal, everything else is zero. Because what happens here is eventually you can use this identity. If you get an identity times something else, well, this is 4, and let's say that's -7. That means x is 4 and y is -7. It's telling you results. Okay, it's going to give you a solution. It's not that necessary for this course. I'm just saying eventually when you take a class that's an upper level 300 level algebra course in college, you'll go, oh yeah, that goofy guy in high school told me about this.
Yeah, back in the days that weren't the days of back in the-
So think of it this way. 3 times what is 1?
1/3. 1/3.
What you did here is you multiplied 3 by its inverse to get its identity.
Oh.
Okay.
So what we're going to be able to do here is we're going to be able to multiply multiplicative identity. 3 times its inverse is always 1. 2 times. That's what it is. What we're going to be able to do here is we'll be able to take the multiplicative inverse of a matrix to find its identity. There are. So, what happens here is this whole mumbo jumbo, which I don't even really want to talk about. Neither does the computer. Think of it this way. Matrix A times matrix X equals matrix B. Matrix A times matrix X equals matrix B. If I want to solve for matrix X, I'd have to multiply both sides by the inverse of A to move it. I don't divide though. In other words, what I would do is, remember the button on your calculator was a -1? That's the same thing as multiplying by an inverse. Remember that? So what I do here is that X, this unknown matrix, is going to equal matrix A's inverse times matrix B. Okay. So what we're going to be able to figure out is we're going to be given matrix A, we're going to be given matrix B. So you're going to figure out what two matrices multiply together equal a different matrix by using an inverse. And an inverse to solve for is really, really easy. Let me show you. I want to find the inverse of this matrix. 3, 1, 4, 2 going across. 3, 1's the top row, 4, 2's the bottom row. The inverse of A is written like this. A to the -1. Pretty easy.
Yes.
Here's what we do. We take 1 over the determinant of A. It's a 2 by 2. 2 by 2s are very easy to find.
Would you like to do this with 3 matrices?
I haven't decided yet.
-4. 2.
6 minus 4. So the determinant is 2. Okay? So the inverse of A here is going to equal 1/2. Now I have to multiply it by something. It's a scalar multiple we're going to use here. Whatever you do in this matrix, we're going to exchange the shoots and change the signs of the ladders. exchange the chutes,
So
which-
3 and 2 are flip.
exchange the chutes, change the sign
-4, -1.
of the ladder,
Why are we doing this?
because that's how you find an inverse.
So the identity is on.
No.
It's the inverse.
The inverse is going to equal 1/2, which is a scalar multiple, into that matrix. So the inverse matrix here is going to be 1, -1/2, -2, and 3/2.
The what?
Right, so
Scalar multiple, just multiply everything by 1/2.
exchange shoots.
Exchange chutes, change the ladder. So the inverse of matrix A, B, C, D
Now, how do you spell shoots?
C-H-U-T-S.
C-H?
equals 1 over the determinant of A times exchange the chutes, change the ladders. And that's your inverse. The reason we have inverses is to be able to solve an equation. Okay?
So our inverse is that.
Our inverse becomes that 1, -2, -1, excuse me, 1, -1/2, -2, positive 3/2. Yes, sir. I'm not dividing by half, I'm multiplying. Because that's the rule. I'm multiplying 1 over the determinant times the exchange-o, change-o.
So that's the answer.
That's your answer. So the inverse of matrix A is this. So if I took matrix A times its inverse, it should give me 1s on the chutes. That's all it means. That's all it means.
We try another.
So we're going to do this then.
Why was it so hard?
I don't know. We're going to solve for x. We're going to solve for x. We have a matrix times some other matrix equals a third matrix. That x in the middle is going to be some other 2x2 matrix. We just need to figure it out. We do that by using an inverse. So our matrix A is going to be 4, -1, -3, and 1. Matrix B is 8, -5, -6, and 3. And if you just do the actual hard count of, not hard count, but the hard way of writing it out, I know that x is going to equal the inverse of matrix A times matrix B. So I would take 1 over exchange-o, change-o. Okay? The determinant is going to be 4 minus 3. Determinant is 1. So it's 1 over 1 times exchange-o, change-o. So what's the inverse of A? 1, 1, 3, 4. So this unknown matrix can equal whatever 1, 1, 3, 4 times 8, -5, -6, and 3.
X equals 8, -5,
No! X doesn't equal that. You have to multiply those two matrices together.
I did. 8,
Oh.
-5.
I thought you were just reading it out.
Top half sentence.
No, you can't multiply it like that. You can only add like that. You have to. 2 by 2 times a 2 by 2 is a.
2 by 2.
How many times you write down the first matrix?
I got all of this.
Oh, I hated this stuff. Bringing back memories. This was like 2 days ago. Yeah, but it was bad. It feels like it.
And then we go 8, -6, -5, 3.
You say negative in Spanish.
Negativo.
Wait, really?
See?
We just said it. So, I'm a genius.
No, you're not.
So what's 8 plus -6? 2. 24 minus 24.
7.
-5 plus 3.
-2.
What the heck? Wait, no, sorry. finish the last problem, or last question.
I'm
I'm behind.
Negative 15 plus 12.
Really got nothing.
So what that means is that if I multiplied our original matrix A times this matrix, it would have equaled it would have equaled 8, negative 5, negative 6.
Wait, when does it equal 1?
That's the identity. What you did by multiplying both sides by the inverse is you created an identity matrix on the left-hand side. It's kind of like the same idea when you had 3x equals 6. When you multiply by 1/3 to both sides, you get 1x is 2, where 1 is an identity. 1 times x plus itself. That's what you're creating. It's the same idea of just not writing the 1.
Not quite.
Sorry.
How do you get all of that?
Math. A lot of it.
I know.
How do I get all these numbers?
No, I love that.
Above it? Remember, it's a 2 by 2 times a 2 by 2, which means I'm going to get a 2 by 2. I write down the first matrix twice. 1, 1, 3, 4, 1, 1, 3, 4. Then I start at the top, 8, negative 6, negative 5, 3, and I replicate it going down. That's all it is. Okay?
Hey, Mr. Murphy.
Yes.
Could you toss that star on?
Now, do this one.
Minus.
So you add. Oh, duh.
What?
Ellie.
It's a two-step equation.
Sometimes I like that.
Did you just say no, it's not?
Oh.
Yeah, it is.
You go, it's a two-step equation, and she goes, no, it's not.
AX minus B equals C. Think about what you have here, ladies and gentlemen. You have this. AX minus B is C. What do you move first?
B.
How do you move it?
Add.
So AX is going to equal B plus C. Then what do you do?
Add the matrices.
X.
And more times.
One little trick that I forgot to tell you, or one rule, I forgot to tell you, is whenever you do the inverse matrix, when you're multiplying it to the second matrix, the inverse always goes first. Has to, otherwise it won't work. The inverse matrix has to be written down first in order to make the multiplication work. Okay? It's always the inverse first.
When we add it, like, so the 4 and the negative 1, is it negative 4 or is it 3?
So do you multiply when you add? Let's think about the question one more time, Hannah. What do you think it's going to be?
It's so weird. You never say our names.
Yeah, I've never just said just.
That was a really weird.
Gosh. I've never heard him say, I'm adding. Actually, I think I have. I don't think I've ever heard him say my name. Say her name.
Her name.
Say.
Why don't you just say my name? Why don't you just say Claire? Why are you trying to avoid it?
I like eclairs.
I'm glad I
Yeah,
shared my
that's
name
so
with
weird. I've never heard him say No. He never says
Have
his name either. He says Alyssa a lot.
She's on her phone all the time.
He said that to me one time because he confused me
He
with
says
you.
Christian a lot.
I'm trying to think of like a time he would
Yes, ma'am.
say
He
my
said
name.
during the presentation, you didn't know what my name is. And he never said it. Because I wasn't sure at one point you were
He
saying
knows our name.
Not
Pay
bad,
attention.
but-
It's just attention from 3 to 6.
Friday Night Lights.
I don't know
Oh,
what
man.
she called it.
I'm gonna be trying to find out detention.
Hey, Mom. I'm going to my.
She delete the pictures of it?
Where did you go?
About time you get back, you bum.
She reactivated it.
Last year, our teacher was so open to
She didn't.
All right, so you get to this part here. Find the inverse of A. The inverse of A is going to be 1.
It's
13. There's 12. Oh, I had a hard time.
I'm glad you were paying attention. I was trying to show you to pay attention to details.
Yes, or whatever you say.
Shut up. Negative 6 minus negative 18 is 12.
12. Where
8,
10.
10. It's one of those.
Who's this
Well,
going to
8,
be this
10.
time?
I don't know. Hi.
Come in.
Yeah. So we have 1/10.
Well, language was you speaking.
times
I didn't hear.
exchange-o, change-o. So my inverse is going to equal negative 1/5, negative 3/5, 3/10, and 2/5.
Gross.
It is gross.
It's a dirty.
Multiply that by,
Oh, I already did that. No, I didn't the exchange. No, I did the exchange. No, I did the exchange or change it with the 3.
I'm not going to lie, inverses, when you multiply them out a lot of times, you're going to get really crummy looking numbers. It happens. It's just math.
It's just the way it rolls.
Oh,
I don't know. People are all just weird today.
I was going
I really
crazy this
was.
9
morning.
days left in school and Mr. Murphy says
For the first time.
I've said your name before.
you haven't. I think you
I
have.
go back.
Not
No, I remember now because when you handed out the clickers, you were calling like everyone like
No, he said-
Allie,
he says his
Catherine,
name with a
and then
lot
you
of, like,
said
with a
Miss
lot of
Hickey,
names.
Miss Eaton.
I do that all the time, but I do that.
But when
No, so like you
when
really
she's
have
gone-
not said
No,
anything.
when she's
Whenever she's
gone.
gone, you always say, "Where's Hannah?"
Where's Hannah at?
But I never heard it.
And
Watch the
Watch it.
video.
Say it. No.
Where's
Hannah?
I can't see it.
I don't know what's going on.
He just said it.
Can I just eat my carrots and be happy?
No. To be honest,
That would be the one.
What's his name? What'd you say?
Petrie. Petrie. Petrie.
Oh, I thought you said.
I was
Yeah,
thinking-
I thought it was like.
I was on fifth grade. Oh, well.
For some reason, I thought Phoenix for Ferrari, like Farari. Right?
That'd be a cool name.
I mean, that was cool. Because you're
Like you guys look the same.
yeah.
I don't think you've ever said Weasley.
You know.
Haha.
You definitely never said me.
He probably doesn't know.
Yeah.
Yes.
He says it all the time. He's always like, "We're gonna do this problem."
Only yours at
Or,
birth.
we already did that.
Oh my gosh. He's never said my name now that I think about it.
He said your name.
Elliot.
Can you just go through and say everyone's name?
I'm busy.
You were literally just staring out the window though.
We talked about
Wait, there's
school
no
breaks for like 15 minutes.
Yeah, I think my dog.
We have time.
No, my dog's name is Claire, I promise.
See, I say Mr. Murphy.
Okay.
Claire's named after
I
your
think
dog.
you're lying.
What did you say?
Yes, I am named solely after Julia Dietrich's dog. That was your dog?
Huh? She's 6.
Yeah, you see, I had no name for the
But in
first 9 years
but
of
in
my life,
first
and
years,
then
that dog's
was
like
gone.
16,
Okay,
36.
I said that's what I said.
You tried, you know, effort. Effort was there.
42 actually.
Nobody asked you.
Make it worse.
Yeah, I did.
I'm giving you guys more homework now.
How about you just kick Alyssa out here?
That's illegal.
Fail her. Fail her.
I'm not taking this class ever again.
I think we get 33 over 10 for one of them.
I know. I got 30 all the time for one.
Yes, 33 over 10.
Is it their first one?
Yes, it is. I think
It's 33 over 10.
we should just not.
Allie, stop.
I see a pencil. It's on the ceiling.
What are the other ones? I know one of them. Hey guys, real fast. Obviously, multiplying fractions and numbers is hard. I know. But you will have a dummy calculator when you have to do this. They have fraction buttons. Just use the fraction buttons. They'll give you.
All right, all right.
Oh, yes.
Well, I'll give you a dummy calculator.
I love dummy
Okay. So I believe you get. Let's see.
They remind me of you.
I literally just said it.
Whatever.
Boy.
Christians.
Good fault, buddy.
Come on, we have like high school. He had messed up with my math.
Homework.
I need a longer pencil.
That's what I have.
Brianna, I need to explain this problem to you now.
Easy.
So number 10,
Hurt
I
somebody.
don't know how it gave you like, it gave you the stuff you needed for P.
Okay.
When you end up getting through violation, I just have been getting
Listen, and then I did that too, and then you ended up with the amount of moles. And I realized that's
it was
the moles of
number-
gas that are in the box. And then it gave you the percentage that was oxygen. So I multiplied the decimal times the moles. And then I got that number of moles, and then I converted it into grams per liter. Doesn't that sound like it would be right? Because you're finding the amount of moles that are in the container. Yeah. Yeah, I got like 1,500. But I mean, that's what sounds right. Like, it makes sense though. Like, if you find the total amount of moles of gas in a container, and it gives you the percent of it that's oxygen, so you get that percent of the mole.
Do you want